Good evening, and welcome to Kopernik Observatory. My name is Drew Desker. I'm the director here at Kopernik. It's great to have you here with us this evening, and also want to welcome those watching on the live stream. This is going to be a big weekend for us. Tomorrow we are actually celebrating our 50th anniversary as an observatory and informal science center up here in the Southern Tier. We're actually doing a pretty major 50th anniversary gala at the thank you, at the Doubletree Hotel tomorrow, and really looking forward to that. And but anyway, let me see here. By show of hands, who's here for the first time? Okay, just this row right here. Okay. Kopernik belongs to what's called an Association of Science and Technology Centers, ASTC, and we share each other's memberships, if you will. So a Kopernik membership gets you not only into Kopernik, but it can get you into the Museum of Science and Technology up in Syracuse, or you can go down to the Franklin Institute down in Philly, or the Intrepid down in New York City. There's over 380 other science centers you can get into with a Kopernik membership. So if you like that kind of thing. Also, you'll find out that a Kopernik membership is pretty cost-effective compared to some of the other places. And so, in fact, I took my daughter down to the Franklin Institute, and just the two of us, I had to pay the regular price for just entry. It would have been more than a year's membership here. So it's certainly worth considering. On our website, we always keep you up to date with what's going on. We normally post our Friday night programs, and actually next Friday night program is actually special because it's our AstroFest 2024. This is a yearly astronomy festival. This is, I think, like the 42nd year that we're doing it. We've got speakers not only on Friday, but then all through Saturday. We get some great raffles, and so definitely worth coming back and checking out. And then later in the month, we have a special event called Hocus Pocus. It's a haunting night at the observatory, so we invite you to get dressed up as your favorite space alien or whatever you wish, and come on up, and we'll have some activities, and as there's always treats in each of the rooms. But again, tonight's program, actually we'll get to that in a second. Every Friday night we do a public program of some sort. On a wide range of topics. It's not always about astronomy, although today certainly touches in that general vicinity. But it's an opportunity for us to just sort of continue our learning. I mean, especially for you youngsters here in the room. Learning doesn't stop at grade 12 or grade 16 or whatever. It's really a lifelong activity that you should engage in, and what it does is it really, quite frankly, I wish I could live another 40, 50, 60, 100 years. When I was your age, I used to have to walk to the TV to change the channel. Now, it just shows up on my phone, and who knows what the next 50 years, 100 years is going to prove from a technology standpoint. So I would love to sort of hang around to sort of see what turns out with that, and that's part of what we do here, is to try to make you aware of what it is that is going on in the world. How does the world work? So tonight's program, called Vital Signs of Planet Earth, today we actually beginning World Space Week. It actually starts this evening, and we're very fortunate to have one of our educators, Jenny Cartie, who we also call our Livestream astronomer, is going to talk about World Space Week, and specifically how the work that we do in space helps us understand what's going on planet Earth, and hopefully we can learn from that and then make make informed decisions on how to keep planet Earth as healthy as possible. I mentioned earlier that we do a live stream. So every Friday night, as part of our Friday night programs, we live stream. And actually, if you go to the YouTube channel, I don't know if you have it up here. Yeah, that's right. You can go to YouTube, put in Kopernik Observatory Science Center, and you can watch us live. If you've got questions, you can ask the questions through the chat. So if you're watching tonight, once you subscribe, you can then actually put questions into the chat, and we pass that along to the presenter. But also, you get a chance to look at all the previous live streams that we've done. And not only do we do Friday night programs, but we've done a number of observing sessions for meteor showers. We've done a number of lunar eclipses. In fact, one lunar eclipse we did a couple years ago, at one point we had over 25,000 people on our stream at the same time. The chat was flying by like a CVS receipt, and people were even commenting, we left NASA's live stream because we like yours better. So definitely check us out on YouTube. So let's dive into this with World Space Week. Again, we're very fortunate to have an in-house educator expert, Jenny Cartie. And so, Jenny, I'm going to turn this over to you.
Thanks so much, Drew. And hello, everyone. Good evening. My name's Jenny Cartie, and I'm going to be taking you through this Intro to World Space Week and the topic that they've set up for this year's Space Week. So let me jump on over to the slideshow here, and I'm going to make sure it pops up on this. Yes, it does. Okay. All right. So World Space Week. And you can see the topic this year for 2024 is space and climate change. Incidentally, Climate Week was just last week, maybe the week before, and it's nice that this kind of just flows right into Space Week for this year. So going from Climate Week to Space Week, and a lot of this is instituted. There's a World Space Week organization, an association that does operate internationally, and is organized with the UN as well, just like Climate Week. So that's where this comes from. And it starts October 4th today, and it will continue on till October 10th. So we're going to be focused on this idea of the vital signs of planet Earth during our conversation here. Before we get to that, though, I'd like to discuss the origins of World Space Week. It was instituted in 1999, so it's still, I suppose, a relatively new international event. And it is the 4th through the 10th every year for a very good reason. It represents 2 milestones in space exploration. And the whole idea is to tie in space exploration into how that precipitates down into our daily lives. What role does space exploration play in everyone's lives here on planet Earth? So let's look at the October 4th and October 10th, that range for a week. It comes from 2 missions, or 1 mission and 1 milestone. The Sputnik launch on October 4th, 1957. This was the first human-made object that was sent into orbit, and not only was it up there going around planet Earth, it was visible too. It was reflective enough that sunlight would bounce off of it, and you'd be able to watch Sputnik fly across the sky. I should mention this too, which you're welcome to come up and look at after. This here, you can see it there. It's a QSL card, and our director could probably explain this better than I can. But it's when you make contact with a satellite like Sputnik, they send you one of these cards. And I still feel like I'm not explaining it well. Do you want to take a shot at it, Drew? Not a shot. You know exactly what it is.
Okay, thanks. So again, Sputnik, what it did was basically it just was a radio transmitter that just basically sent out a series of beeps indicating that it was alive, and that it was alive for a number of weeks. And my father was a ham radio operator, and so he actually happened to have a receiver that was actually capable of listening on that frequency that Sputnik was transmitting on. And So he made notes about that that information, and then sent it off to the Russian Space Agency and said, okay, on this date, I heard these series of beeps. Most likely he heard what's called Doppler shift, because this was probably traveling in the excess of 17,000 miles an hour. You can actually get Doppler shift. So if I was listening on one particular frequency, you might hear like a beep, 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 as just like Doppler would be on when you see an ambulance go by. And but anyway, so he sent a note saying, this is what I heard when I heard it, and they sent back this card saying thank you for that information. And so when you're done, you can come up and take a look at this. It's some loose translation of the Russian. If anybody are clear Russian speakers, please let me know, and we'll have you double check my work here. Thanks.
So yeah, Sputnik pioneering the frontier of space exploration. And if you know the timeline here at all, you know, okay, we hit with this object orbiting around Earth in 1957, and just a little over a decade later, there were astronauts walking on the moon. So really important milestone, and that's why it starts October 4th. Moving on from that, October 10th, that's when Space Week ends, and that was when the Outer Space Treaty was signed, so October 10th, 1967. And that treaty at least sets up a foundation for how we as people, as countries, how humanity should treat objects in space and space itself. Now, most likely this treaty, we're on a cusp of it being challenged in some ways, especially as commercial space becomes more common. So that means private space exploration companies going out and venturing. You know, you may have seen in the news things like they're interested in mining asteroids out there and all sorts of stuff. How can we commercialize space? And something like this is on that cusp of being challenged, and I think it's pretty important. We do refer back to this and modify it too for the modern era, so that space becomes that final frontier that just begs to be explored, and to use it for science effectively, just to pull data from it to better understand our place in space. So that's the Outer Space Treaty. The full name for that is the Treaty on Principles Governing the Activities of States in the Exploration and Use of Outer Space, including the Moon and other celestial bodies. That's a mouthful, but you can just shorten it to Outer Space Treaty. Signed October 10th. So again, this year, they went for the theme of space and climate, which ties into our show tonight about the vital signs of planet Earth. So how does space exploration play a role in understanding our planet? And I'm going to turn off a set of lights here. You got it? Okay. Just so you can see that a little better, less glare. So just starting off, though, I just want to, you don't have to shout out or anything if you don't want to, but just posing the question here of what do you think of when you think of space exploration, right? What comes to mind? And maybe you imagine the astronauts walking on the moon from 1969 to 1972 during the Apollo era missions. This image here is of Buzz Aldrin, the second person to walk on the moon after Neil Armstrong. You can see there are footprints all about. If you look in the visor, you can even see Neil Armstrong taking the picture. And what's really cool too is we have a standee of the same image over here. We've got Buzz in the room. There he is. So that's the first Apollo 11 mission. So maybe that comes to mind. maybe you think of Mars rover Perseverance or any of the robotic explorers venturing out into the solar system and studying new worlds. The furthest robotic spacecraft out there are the Voyager probes. And arguably they've reached some level of interstellar space, going beyond just the influence of our sun, and then you start to experience the influence of interstellar space. So robotic spacecraft have really ventured far out, deep into the solar system. So maybe that comes to mind. Perseverance, by the way, is the newest Mars rover, landing in 2021. And it's been doing a great job exploring the surface. Or maybe you think of Matt Damon on Mars, stranded on the red planet, right? You think about any of the either fantastical or thrilling space adventures out there, especially in the 20th century and now well into the 21st century. Space became a major component of our popular culture, and it continues to be just this look at the final frontier. So we think maybe when you hear space exploration, you think going beyond, right? Venturing beyond in the solar system, beyond our solar system. What could be out there? It's infinite. There's so many possibilities. But what's surprising, if you look at all of these are just the operating and future missions. It's not taking into account past missions. So these are all the operating and future NASA missions that are out there right now across the solar system, and including astrophysics missions as well. Those are up here around this galaxy. So that'd be looking beyond our solar system. And you see the orange is biological and physical. So that's testing ultimately being done in low Earth orbit. And it's focused on biological side. So how does life react to space and space travel? So not just humans, but also plant life and animal life. How does it react to space? Then your astrophysics there, looking deep into outer space. Something like the James Webb Space Telescope. That does do some planetary science as well, but it's mostly focused on reaching deep into the universe and looking at some of the earliest galaxies. Then you have purple for planetary science. So you're going to find those all around these bodies out here, like Jupiter, Mars, Venus, Mercury, Saturn. Just while I'm at Saturn, I'll mention Dragonfly is a really exciting mission coming up that is going to explore Titan. It's going to be another drone or helicopter system like they sent to Mars with Ingenuity, but this is more akin to a drone, a very large drone that's going to fly around the clouds of Titan, Saturn's moon. And then the yellow is for heliophysics. And finally, green is for Earth science. And just to give you a count here, for biological and physical missions, that's around 25 total. Astrophysical missions, that's about 20. Planetary missions, about 40. Heliophysics, about 32. And for Earth, around 40 as well. So all these planets out here that we're exploring in the solar system, all of those combined, all those purple missions, equate to all of the missions for Earth itself. So that's a really important point, I think. So much of what NASA itself does, and other space agencies as well, you're not pointing out. You're not pointing your robotic instruments out to the universe. They're turning right back around and looking down here on Earth to study our planet. And what's super impressive about this as well is if you look at, there was the legend here. Oh, It's very tiny, I forgot. It says future launches in bold. So all the future missions coming up are bold text. And you can see there's a lot of them around the Earth there. So there's a lot coming up. And I think that should make sense. And it should make even more sense as we delve deeper into this talk, is we're concerned about Earth. There's no doubt about it. The vital signs of our planet are in the red. The trend is in the red. And we need to know more about where our planet is going, how we're influencing our planet, and the general trend. And in the end, it's going to help us understand how to mitigate issues with climate change. That was a big pivotal moment for me as I was going through college and everything, is this transition from climate, basically avoiding climate change, right? Doing all we can to avoid or to reverse climate change. That's the word I was looking for. Now it's switched over into how do we mitigate and how do we slow down the possibility of the worst case scenario. And yeah, that was a big moment. And that's what a lot of these missions are designed to do. Now we need to understand, okay, this is where we're at. What do we do now? And that's not to scare you or by any means, but it is the reality. It's our lived reality now, and it's where the data goes. We'll look at the data later in the show. Okay. So, taking a closer look at the Earth fleet of satellites. This is, the last image was as of last October of 2023. This one's very current. This was as of, in the corner here, 9/11 of 2024. So this is a much more current look at current and future missions. You can see in a legend here as well. You have some out here further out towards 2030 that are pre-formulation. The orange circle is implementation. So those are currently either being built or prepping for launch. The green square is operating instruments and labs, and then the diamond is extended. So those are missions that have gone past their mission timeline, but they're still operating, and they were able to get new funding. That's not abnormal. That happens a lot. And it's a good sign. That means they were engineered really well, and they'll continue operating until they either run out of a budget and they don't get funded, or they just die out, which is a possibility. So we're going to look at some of these. I have a couple I'll show you in the presentation here, but a goal of tonight's talk is also to let you go hands-on with some of this data and some of the ways that you can explore what missions are out there collecting information about Earth. So I won't even go through, because I'll be honest with you, I have no means of memorizing all of those acronyms and telling you exactly what they are. But that's part of our goal today, is to just explore those. So, vital signs of Earth. This is what a lot of these orbiting labs are studying. And let's just look at them right here. So, you'll notice an immediate trend with these. Most of these orbiting labs are studying features and characteristics that are related to climate change. Because in the short term, that's what we need to understand. Longer term, we are of course interested in general planetary science, and Earth science. So this does come into play where you're looking at other places in the solar system that could have a biology on it, a biosphere. Something like Enceladus or Europa and their large oceans underneath icy crusts. Like, those planetary sciences come into play back here on Earth. So there is that study going on, the larger study of the formation of biology over time and so forth. But short term, this is what a lot of these instruments are focused on. And going through them, you have carbon dioxide, global temperature over time, methane, sea level, the ice sheets, the ocean warming, and Arctic sea ice, a minimum extent. Let's talk about what those mean. Some of them, I'm sure, you know right off the cuff here, but if we add some captions, let's look at the two greenhouse gases that are primarily measured: carbon dioxide and methane. Other greenhouse gases are measured as well, but these are the two that we're most concerned with. And most of the excess carbon dioxide and methane that's being sent into the atmosphere is coming from us. It's coming from burning fossil fuels, and these are products of those reactions, the combustion reactions. Methane leaks, for example, are also a really big problem. When your methane we can use as a fuel source, and when you burn that methane fuel, it will become carbon dioxide as well. But a lot of methane gets leaked out. It's part of our agricultural systems. And methane itself is even more potent than carbon dioxide in terms of a greenhouse gas. These greenhouse gases, if you think of a greenhouse, right, you got sunlight funneling in through the structure. It's able to retain and trap that energy, that heat from the sun. And these greenhouse gases are able to absorb and store that heat energy as well, retaining it instead of the more natural cycle of releasing that energy either back into space or utilizing it another way. So those two are, they share an interesting dichotomy, I guess, too, in the sense that methane is potent, but it has a shorter decay time. Methane, on average, around 10 to 12 years it takes for it to decay in our atmosphere. That's not too bad. Some of our concerns with methane, with major call them like turning points in our climate, major triggers that are kind of primed, is methane stored in the ice caps. So if that methane's released, it doesn't matter that it has a short shelf life, it's going to make an impact immediately. Those are the issues with methane. Carbon dioxide has a longer term effect. It does, as soon as it's in our atmosphere, it does start functioning as that greenhouse gas, but it takes thousands of years for that carbon dioxide to go into some place else, to get stored as carbon, at least the way the trend is set up now. The amount of carbon dioxide we're releasing, the planet can't keep up with that. And some of it ends up getting stored in our oceans, which we'll talk about when we get to ocean warming a little bit. And you end up with these chain reactions that are starting to build up with those greenhouse gases. So these are the two. Carbon dioxide and methane are the primary causes of global warming. And that leads us to global temperature. When you look at these two side by side, you see this increase in carbon dioxide, especially once we head into the industrial age. Boom, carbon dioxide starts going up, and then trailing carbon dioxide, you got your temperature spiking. And that's exactly what you'd expect. You're pumping more of a greenhouse gas into the atmosphere. So the 10 most recent years are the warmest on record. since we've been able to take temperature records. And I think we know kind of intuitively at this point that that's the case. Think about our winters here, right? If you've been around a bit, you know that we're not experiencing nearly as much snow or colder temperatures during the winter on the average. You get like a window during late December into January where it is very normal cold temperatures that you'd expect for winter. But as you head into February and March, it starts warming up again, back to mild temps. We're experiencing fairly mild temps right now as well, and that will most likely continue into November. So that I think we know intuitively, that something is different about our experience. And it's not just a ebb and flow of that what we'd experience with the seasons, right? That we'd experience with even just normal, shorter-term trends that you expect in climate. This is a drastic difference compared to what we've experienced as humans for the last 1,000 years. Okay, then we have sea level. That's rising due to global warming, and it's not just rising because we have melting ice caps. It's also rising because of the nature of thermal expansion. You're putting more energy into the ocean. We got to interrelate these two right now. Sea level and ocean warming. 90% of global warming happens in the ocean. That's where most of the energy is going right now. And that absorption is going to cause the water to expand. And if you look at a cup of water and you start heating it up, you're not going to notice that too much. But when you're talking about bodies of water as large as our oceans on Earth, it makes a significant impact for that to just increase in size just a little bit. So some of the sea level certainly is coming from ice caps melting and glaciers melting. But a lot of it is also coming from thermal expansion. So those two are related. Carbon dioxide is also getting absorbed into the ocean. The ocean is helping us quite a bit right now. It's absorbing excess energy. It's absorbing carbon dioxide. And one of the unfortunate things about that is that even when let's say we flip a switch right now, we turn off the carbon dioxide taps. We're not burning fossil fuels anymore anywhere across planet Earth. The ocean helps keep us in equilibrium. And what's going to happen is the atmosphere and the ocean will have to catch up with one another. So all of that carbon dioxide that is in the ocean, now that carbon dioxide levels are dropping in our atmosphere, it's going to start funneling out from the ocean. So you'll have this window, even if you were to turn off carbon dioxide right now, where you would need to catch up and re-equilibrate. But it shows you the power of the ocean, and it makes sense. So much of our surface area on Earth is made up of our oceans, but it is helping curb some of the issues we could experience otherwise with climate change for now. Then we have our ice sheets, and those are, of course, melting and contributing to sea level rise as temperatures increase. And then Arctic sea ice minimum extent. It's just a long way of saying you've got your ice caps. Every year they'll experience summer, and that minimum summer ice is what you're looking at. And it's been going down by about 12% per decade. So those ice caps are shrinking. All right. So that's an overview of those vital signs that we're watching. We want to watch with our orbital spacecraft. And I want to start us off with the International Space Station, because there's quite a lot of climate science and earth science going on the ISS. And I'll just show you quick. This is what the ISS looks like. And it's the size of a football field. Most of its size comes from those large solar panels you see there. There was a flyover tonight of the ISS around 7:30, I think it was, but it was a very low flyover, so it was not much to see tonight for it. But sometimes we get the high flyovers where you can see this bright starry object in the sky, and you can follow it, and it just looks like a point of light moving across the sky. Very much like what Sputnik would have looked like. No blinking lights or anything. It's all just sunlight reflecting off the panels in the structure. So the ISS, that's where astronauts go, both from the United States and other countries. And it orbits 250 miles above Earth once every 90 minutes. So that's why you can have the opportunity to see the ISS in the sky multiple times a night. And it's moving at that speed of 17,500 miles per hour. And at that speed, you can travel to NYC to LA in less than 9 minutes. So this thing is booking it. And you can really tell it's moving quite fast for an object in the sky as well. So it's where astronauts go, but it's also where there are a lot of instruments on board collecting scientific data in a number of fields. Among the other things they do is they give this interesting perspective from a fairly low orbit satellite. You can actually look up live streams of what the ISS is looking at all the time. And this is what the astronauts have the chance to see. So if we play this recent clip here, very recent, this is a flyover from the ISS of Hurricane Helene. And you'll find that whenever there's these big storms happening, or big moments across our planet, you'll get footage like this coming down from the ISS. So we'll fly over the storm here, and eventually it almost goes right over the eye. And this is real time, so it's going to look a bit slow, but. They'll move the cameras around a little bit like you're seeing there as well. I think eventually we even see, now we're starting to see some of the craft now. I believe that's the Canada arm, one of the robotic arms on the ISS. Yep. Now we tie in, I chose this video very purposefully. I could have shown you anything. Beautiful aurora across the poles when the ISS flies over. That's worth looking up, by the way. But I chose this storm system with Hurricane Helene specifically to relate back to this idea of ocean temperature rising. All of that energy from global warming, 90% of that going into the oceans. And when we feed more energy into our oceans, we get an increase in storm systems like this. You're adding energy both into our atmosphere and into our bodies of water. And in turn, you get an increase in storms like hurricanes and severe storms like hurricanes. Hurricane Helene was a particularly tragic storm that affected multiple states. And if you watch the satellite imagery as well, you can see that storm system survive for quite a bit because it's pulling so much energy from those oceans. So that energy goes somewhere, and it goes into hurricanes like this. There are a couple of systems now, I think, that they're watching, and we'll see that in our NASA EYES app exploration. It's one way to track major events that are happening. So yeah, flying right over the eye of the storm there. And you can see those arms of the hurricane swooping out. All right, so that was the recent hurricane. And that's one way the ISS can monitor what's happening down here on Earth. But there's also specific instrumentation. It's not just visual. You never want to just collect visual data. So these are some of the instruments that are there. Going through some of them, and like I said, I will have to look at some of my notes here for the acronyms because some of them get a little crazy. So let's see, I went left to right. So SAGE 3, the system right here, that is the Stratospheric Aerosol and Gas Experiment. So that is almost exclusively focused on aerosols and their effects on things like the ozone layer. So one of the major projects that was done internationally was to effectively get rid of CFCs to the largest extent possible. And CFCs were responsible for damaging our ozone layer. And so there was a large hole in it for some time. And the ozone layer helps protect us from things like ultraviolet light, helps absorb that. So we need to keep that safe. You don't want holes in your ozone layer blasting UV light down on you. If you've gotten sunburn, you know why. But if that's with an ozone layer above you, what happens when it's not there? It's a major protective barrier. So SAGE 3 is at least partially responsible for monitoring those ozone levels and the aerosols going into the air as well. All right, then up here, TSIS 1, which is Total and Spectral Solar Irradiance Sensor. Mouthfuls. That measures the amount of sunlight that falls on Earth and how that light is disturbed among UV visible and IR wavelengths. OCO3 down here is the orbiting Carbon Observatory. There's also an OCO2, and that is not aboard the ISS, that's in its own orbit, its own instrumentation. I'm just going to call this one here JEDI. The Global Ecosystem Dynamics Investigation, and that's focusing on deforestation and the effects of climate change are having on deforestation. Well, deforestation itself is ultimately human-driven. So you're removing those carbon captures from our environment, and when you do that with old growth especially, that's a problem. Old growth forests are really important for carbon storage, and when you send that back out into the environment, that system's not going to be able to recover. That ecosystem won't recover the same way with new growth forests. So you can replace all the tree, old trees with new trees, but you're not going to end up with the same result. And that's something that JEDI would be studying. And then eco-stress. It's the Ecosystem Spaceborne Thermal Radiometer Experiment. And that measures the loss of water through plant life. So what is that water cycle in the biosphere itself? All right, the next one I have a slide for. This is a upcoming mission called Clario Pathfinder, Climate Absolute Radiance and Refractivity Observatory Pathfinder. And that's launching within the next couple years. It measures sunlight reflected by Earth and the Moon to detect climate trends decades sooner than previous missions. I think their patch in particular does a really good job of showcasing what it's measuring. So down here on measuring the reflective sunlight from the surface of Earth, comparing that and calibrating it with the Moon, and looking to the full solar irradiance of the sun. it's that combination that's going to allow them to detect these climate trends moving forward. And then there's SWOT, which is the Surface Water and Ocean Topography Mission. It is in orbit right now in its own solitary orbit, and it's making the first global survey of Earth's surface water. So that's just a handful of missions, and those are the only two I have on my slides. I could certainly read to you all the missions that are out there, but I think what's more interesting is exploring it through Eyes on the Earth. And Eyes on the Earth is a NASA web application. And you can also download a true app version of it on Android or iOS. But I would say the web app is better. Just log into this website here. And that's actually what we're going to do now. That's why I have these iPads up front. So you can explore Eyes on the Earth yourself where you are in the room here. And I'll give you a little tutorial on how it works as well. So let's do, I will say for those on the live stream, just put that web address into your web browser, and then you can load this up as well on your end. So if you would like to participate in this, you can come up or we can pass you an iPad. All you do, I'll grab one here. Is you're going to click the home button on it, and it's going to wake right up into this app. Oops. All right, let's jump over here. We'll get back to that one. We want this one. All right. Those that have one, perfect. So let's explore Eyes on the Earth. And this is primarily focused on global climate change and the vital signs of the planet. But you'll find some other satellites here as well. So first thing you can do, and maybe you're already trying it, is you can click and drag. And you can orbit around Earth. On your iPads, you'll have to tap and drag. So we're moving around the equator here right now, but you can also go up around the poles. All right, so you get just about a full scope of Earth here. Now, most apparent are these little red circles you'll find dotted around the planet. These are marking major events. It does tell you up at the top, the latest event is Typhoon Krathon, I think is how you pronounce that. And you could, of course, just tap that and it'll take you right to some of the latest satellite imagery of that typhoon. You can do the same thing with more recent. If you ever need to leave a section, you just click back. So I want to rotate back over to these two dots that represent, this one I think is going to represent Hurricane Helene. Nope, that's Hurricane Francine. I think Helene's this one. So that is Hurricane Francine from back on September 11th of this year. Then if we come down here, that is Hurricane Helene, satellite imagery from September 25th. So important to note that this is not large-scale, or I should say short-term satellite imagery, so you're not necessarily going to be able to capture a full scope. That'd be more something that you'd find through NOAA's day-to-day captures in satellite imagery. A lot of those satellites were worked on by NASA, but they're operated by NOAA. So they're focusing more on day-to-day weather systems. NASA is focused and funded for climate change. So they're looking at a larger scope. And that's what their satellites are doing. So you can create time lapses, but they're not going to be moment-to-moment time lapses. They're going to be more day-to-day and week and month terms. So you can see it's tracking here. We can look up in this section and see how these hurricanes have changed over time. That's Helene right there. We can watch it again. This is the 29th, and the storm is tracking that away. So you can create time lapses. If you click on the calendar, you can also add a new start time, add a new end time. But you can't just choose anything. You got to click through the calendar and select it that way. But again, we're looking at a grander scale here. This is the visible Earth, but you can also go through all those vital signs as well. So looking at air temperature, for example, you can see the current air temperature across this gradient on our planet. This is in degrees Fahrenheit. So your blues are going to be 0 degrees. Out here, 30 going towards 32, you get greener and then to a brighter color. So those are going to be your more temperate zones. And then out when you get into the yellows, oranges, and reds, those are going to be higher temperatures. So 75 is a red-orange. And you'll find all those redder, darker colors around the equator. But you can see that all those higher temperatures are even still heading into the fall in the northern hemisphere. No, we are in the fall. But you can see those high temperatures still residing across the southwestern United States. So let's see what we want to do next. That is air temperature. We can also go to carbon dioxide concentrations, and we can create our time lapses. Oh, this one is good. This one's CO2 since 2002. So this is showing concentrations of around 380 or so parts per million. The dates are 2009 right now. But you can see it's just going to keep ticking up into that spectrum and eventually get into this redder coloring here, which is out towards 410 parts per million. So ideally, we would not be at this level right now. 410 parts per million is not where scientists would like us to be. We should be around 350 is the ideal scenario. But to curb us back to 350 right now would take some tremendous action across the globe. And it would also take time for that cycle to catch up, like we talked about earlier. So we're heading towards the 450 marker. That's the trend, because right now we haven't made enough impact on our fossil fuel footprint and our carbon footprint to send us down. We're trending upwards. And 450 is kind of the limit that they'd if we get past that, if you're talking like 500 ppm, that's where we're going to start experiencing short-term and then long-term major climate impacts and major effects to the biosphere. Not that we aren't already experiencing that now. I mean, you hear about like coral bleaching out in Australia and across the globe, but that in particular, the Great Barrier Reef, reaching a point where it might not be able to recover. We're seeing that in our current lives. So we really got to trend that back down, get it to slow the trend, and then hopefully one day reverse it. So the other way to look at this as far as a high limit, where the barrier you don't want to cross, 450 ppm, or you're talking about global temperature, which in an ideal scenario you do not want to reach a delta of 1.5 degrees Celsius. That's an average delta over a long period of time. There's two ways to look at it, but you can see that they're interrelated, right? Carbon dioxide emissions and concentration versus global temperature. Let's see. They are tracking other gases like carbon monoxide, which isn't a greenhouse gas in and of itself, but it is a product of things like cars and volcanoes and forest fires, and can be indicative of future climate trends. They're tracking chlorophyll. We've got our sea level. That'd be a good one to jump to. This one will bring way back here, as far back as we can go. And that's fine, we'll leave it at that. So this is cycling from 1994 to our current levels of rise, and some places where you'd expect major impacts to happen. Where you hear more about it in the States are areas of land that are already pretty flat. So along their coast, they're going to experience larger impacts, even with minute sea level rises. It comes into play with hurricanes too. Storm surges are getting stronger in part because the sea levels are already high. So you can see there's a flux too, and that temperature plays a role there as well. But the trend is going to keep skewing towards those higher level colors. The red, we're looking at, like the red over here you're starting to see. Tracking ozone, like we talked about before, ozone concentrations, and monitoring whether there's the possibility of a hole forming, and if so, why that is. We need to make sure the ozone stays stable. And the ozone is an example of protecting the layer, rather, is an example of that international coordination that we need today with climate change. But there's a lot of hurdles, societal, commercial, and otherwise, that currently prevent us from making those changes that we need to. All right, so you can also scrub through the missions. I like this page as well because you can see right away how long those missions have been out in space. So Aqua, Aura, there's our eco-stress. So Aqua's been there for 22 years and 154 days in orbit, and it's still going. There's some more recent ones, like the 4 tropic satellites that have only been there for about 1.5 years now. Let's take a look at one of the ones we talked about, if it's here. Yeah, we can jump to OCO3 and maybe then go to SWOT. When you click on a mission, you can get a description. So this is OCO3 aboard the ISS. And what's kind of neat about this instrument is it was built off of spare parts, almost, from the OCO2 instrument. So they were able to put this on the ISS. And it was a great example of realizing resources, not letting them go to waste. They realized they could put a second instrument together, and so they did. Okay. Go back missions. You can also take a look at SWOT. Like I said, this is an independent satellite. And it also tells you the launch vehicle. So this is a more recent satellite that was sent up, so it used a SpaceX Falcon 9. Whereas if you would go to Aqua, let's see if it even labels it. Oh yeah, yep, it tells you Delta 2. So you can bounce around to all these missions, and my goal here is to just provide this resource to you so that you can explore at your leisure. See what all these space explorations are monitoring, see where they are. You can scrub through time to watch. Let's go back out of this so we can see the overall view. Okay. So you can speed through time, see where they'll be in the future, or you could go the opposite direction and see where they were, what they were monitoring. There's the ISS tracking along. This is one way to track the ISS. It's not the best way. You can look up various applications for your phone to see the exact times and whether the flyover will be good in your area. But it is a method to see if it's going to be near you at a given point. All right, so that's eyes on the Earth. And you can keep those iPads right with you for now. And that's fine. What we'll do as we wrap up here, I want to show you where this data goes, right? We're collecting all this data from these satellites. Where are we sending it? How are we putting it together? And of course, it's in graphs and charts. So there's a secondary website under basically the same name talking about vital signs of planet Earth. And you can go through each of those vital signs and see the latest data and trending backwards as far as we've been able to collect it. So carbon dioxide, the current average estimate is current average measurement is 426 ppm. And again, that trend is going up when we ideally don't want to go past 450 to avoid the most harmful effects of climate change. And you can also get a quick highlight takeaway for each of these. And some of these I had in the previous slide, but this one here is saying carbon dioxide in the atmosphere warms the planet, causing climate change, and human activities have raised the atmosphere's CO2 content by 50% in the last 200 years. And this chart, which if you've looked into climate change in the past, it'll look familiar to you. It's kind of the chart that you show to be like, well, that's obvious, isn't it? Because it's showing you CO2 concentration over time. Some of it is coming from, like in the modern era, right? This trend right here in red is coming from instrumental data from those satellites that are in orbit. The orange line, though, is coming from ice core data. So if you go venture up to the ice caps, you can drill into that ice. And the deeper you go, the further in time you're going. So you can reach back. If you look at the scale here, it says all the way to the start of this, 800,000 years before today. So we're able to reach deep back in time and look at the CO2 concentrations of that atmosphere that's stored in those cores and those ice layers, and look at the measurements. And you can see that there's a pretty regular trend happening, a natural trend, but then industrial age hits, and boom, it skyrockets. Again, that should make sense, because we're releasing carbon that was stored, carbon that was captured in fossil fuels, like oil, like your petroleum products, and so forth. Now we're releasing that. We're burning it, and that becomes carbon dioxide. And like we said earlier, it stays there for thousands of years. It's very hard to pull that back. So given the natural cycle of our planet, that carbon wouldn't be released in such a short period of time. And because that's happening, the way you can think about it is planet Earth is going to still be here, right? Earth is going to be fine. It's us. We have the problem, and that is what we have to solve if we want to have a nice, diverse biosphere, for one thing, which we should all want. We want to have a healthy ecosystems across our planet. But just from a pure survival standpoint, we are not necessarily taking the right actions that we need to. And let's look at this trend, right? I'll even do it in another window compared to the global temperature trend over time. And this one's going back to the year 1800. So you're looking at that industrial era. Concentration levels are going up, right? They're going up here from 1960 to into the 2020s. You look here, this is 1911, skyrocketing. And again, you can see this. There's been a lag, right? This looks pretty stable. That looks nice. But now we're starting to feel the impact. And that trend is just going to keep going up unless we change our behaviors across our planet. Here's another view of that from 1884 to 22, a visual map of temperature differences. Let's zoom in a little bit. There we go. This is showing you a temperature delta. And yeah, you can start to see we're entering into the higher end of the spectrum here. We are in, does it tell us the current date? I do not see that. We're about over halfway through now. So we're starting to reach into this area of the chart now. The spike. And all that blue starts to fade away as we enter the modern era. All right. And another resource I like from NASA is the Climate Time Machine, which is just another way to sort of sift through this data. We'll look at carbon dioxide one more time. It tends to show you this in charts, and we'll let this load a second while I kind of conclude things here. Again, the challenge with talking about climate change, and I'll be honest, going into this talk, you're not quite sure how to frame it, especially if you're not talking about it day to day. That's not my day job. I did study sustainable energy systems, so this topic was an important part of my area of study. But currently I'm not talking about it daily. So it's also challenging to talk about it in any major positive light, given how much the data points in one direction, right? And how much we're experiencing in our lives the changes and the impacts of climate change. So you run into this difficult area, right, in science outreach. I'm just talking about something that we're making it seem so dire, right? How do we avoid that? But I think the truth of it is you can't. You can't avoid talking about the data and where it's trending. What you can start to consider in your own personal lives is how can you start to get active? And you're doing it right now. You're attending this talk, talking about the vital signs of our planet. And that's an important thing. And if you've done it in the past, or if you're looking to do that in the future and get active and involved in this space, that's good. It's best to stay active and not let it take you down, but let the concept of this new era we could enter, building up community, focusing more on sustainability and our locales, right? Building up our local community. There's a lot that can be done there. And there's not much impact you can immediately make on the larger global commercial infrastructure, right? As nice as that would be, you personally can't turn off the tap of CO2 in a snap. But if we keep talking about it and if we keep moving forward and even to put it bluntly, like start looking at the nature of our politics too, and think about voting in that right direction. Like that's the power of this, because we can make an impact in our personal lives in those small ways. So it's a challenging topic, but we talk about it, and that's what I think is really powerful too, is NASA is focused on it. So much of what they do. If you're looking at planetary science as a whole, half of planetary science is focused here on Earth. That's powerful, and majority of that planetary science is focused on climate change. So, yeah, keep considering where these trends are going, but and consider this eyes on the Earth and a way to monitor our climate systems. And with that, I just want to double check that was my, yeah, we did talk about the data. Now, if you have any questions about either eyes on the Earth, I'm happy to take you through a section of it if you need to see if I missed something and you're curious about it, or any other questions about the talk. I'm happy to take those. Yes, Mark.
Would Sputnik still be up there, or has that long since been down?
Good. So the question was, would Sputnik still be up in orbit? And I am honestly not sure. Do you know anything? Okay. I wasn't sure how high up it was. Yeah, then that's the answer. I wouldn't know myself, but yep, it's back. Or burned up in the atmosphere. Mm-hmm. Any other questions? All right. Well, anything from the chat? Nope.
Well, there was a comment from Doug. It says, if trains and trucks generate more CO2 than pipelines, why are we banning pipelines? And if we're not self-sufficient for fossil fuels, we have to buy them on the world market, which means CO2 is shipped here, generating a lot of oil is shipped here, generating a lot of CO2. Any thoughts or comments on that, or? Okay, I'm sorry. This is, if trains and trucks generate more CO2 than pipelines, why are we banning pipelines that are also safer? Or is it?
I think at least what I would take away from that is like you're kind of looking at two things that are of the same problem. You're talking about a pipeline, and you're talking about trains, trucks. You're talking about our transportation infrastructure. As far as banning goes, yeah, you can't ban any of those things just in a snap. But both of them are contributing to the same problem. And when you look at these CO2 emission charts, I didn't have one in this talk. It wasn't necessarily the focus. That gives you, what's making the most impact would take you into a whole other area of this subject. But in the end, we have to curb those CO2 emissions from all areas of our infrastructure and our world. So, I'm not. That's also a political issue too, as far as like what are we turning away, what in terms of new infrastructure versus what are we building up. So that's my point of reference, though, is like we should be looking at all areas of our infrastructure. Any other?
Thing on Sputnik. Just a very quick one. Sputnik was actually only alive for 22 days due to they only had batteries on the inside keeping it going. So, or at least keeping the transmitter going. And for those tech geeks out there, it was actually transmitting on both 20 megahertz and 40 megahertz. And so again, like a lot of ham radio operators like my father, had equipment that could, in fact, listen on those frequencies, and were able to, to pick that up. And so ultimately, after 3 months in orbit, on January 4th of 1958, it finally re-entered the Earth after 1,440 orbits of the Earth.
All right, so just one last point of reference here. I guess I didn't have the slide pulled up, but there is a website you can go to for World Space Week, and you can see all the other events that are happening. Let me just pull it up quick. World Space Week. Yes, Mark.
I showed it at watch on Friday, so what's up?
Mm-hmm.
Just gonna watch it. He said that tonight and tomorrow you should be able to see the northern lights.
Yes, yeah. There was a big X-class solar flare that popped off on the sun, and it sent 2 major CMEs heading our way. There's a decent forecast for in the early morning, heading into the early morning on October 5th. And then the bigger CME is supposed to hit on October 6th. So stay tuned this weekend. I don't think the forecast looks good for this evening into the early morning, but maybe come October 6th, that next CME that hits, we might have good luck there.
Try going to the Alaska aurora forecast. You know how to do this.
Alaska aurora forecast.
They actually created a new feature that just saw today. They're actually going so almost like 2 hours by 2 hours. Right. Those little lines up in the top.
Oh, nice. Okay, so yeah, and during KP, is this our current, local Eastern time, KP7 around 8 a.m., that does not do us much good. That'll be too bright. But yeah, this looks, here, what's this? 11 p.m. October 5th is projected KP7. Wow.
You want to scroll down and show them how to see the North America?
Oh, thank you. So we're currently Saturday, October 5th from 11 p.m. to 2 a.m. That's showing KP7 as well, and I think conditions are supposed to be clear tomorrow night.
Yeah, tomorrow night's supposed to be
What
windy.
does KP7 mean?
So that has to do with I guess it's the energy of the storm system, and its prospects for entering into mid-latitudes and more southern latitudes. So like if you go to spaceweather.com, that's another good one where you can get some up-to-dates of flares that have gone off and some of the latest data that's coming through, like if you scroll down here. So it's saying KP is about 3 1/3 at the moment, but we should start seeing a spike within 24 hours, and KP7 is your G3 class geomagnetic storm, and that one is where we would start getting a strong storm here in our skies, strong northern lights. This image, if we go to Astrofest, the background there, I don't have the other image otherwise readily available without the Astrofest text, but there you go, Astrofest plug. That is about a KP7 or a G3 class storm that we saw here on August 12th.
Now, was that what you saw naked eye?
The coloring was muted, so you could tell in some spots certainly that there was greens and there was those pinks and reds, but the structure was there. You could notice the structure, and you could even at the peak of that storm, you could really tell that it was flowing and moving. So once you get to those higher levels, if we got to KP8 or G4 storm, that's when that color would start to get even more prominent for us here. Okay, so World Space Week, last thing, if you go to this website, you can look up a global map of World Space Week events. Some of these will be virtual. Some of them are on site, but it's not letting me go to the US. Let's go that way. And this is a nice way to browse what's going on across the states over the next several days. And yeah, you can take a look. Some of them will list what they're going to focus on. So yeah, if there's no other questions, that concludes the talk on the vital signs of planet Earth. Thanks for tuning in tonight. I'm not sure what the conditions are like out there at the moment. Not good. Not good prospects for observing, I suppose. But maybe tomorrow night, stay tuned for maybe some of those northern lights. And again, thank you again for attending.